Yeah. Hello friends. We are in the aero modeling laboratory of IIT Kanpur. So we have done enough exercises in the classroom. So let's now have some fun flying some of these models here. Yeah. So you can have a quick overview of this lab. Meanwhile, so the motive of this outing from the lecture hall is to demonstrate whether we can fly a flat plate or not. Okay. So for that we need a planform which is a flat plate, right? So what do we need for a flat plate? How to make a flat plate fly? So first of all, let's pick some flat surface out of styrofoam which is easy to easy for me to handle. So these are we have some of them here, right? So let me pick the biggest one. So I am keeping these two styrofoams aside. Yeah. Yes. So I can see, you can see this is a flat plate, right? So maybe thickness is close to say around 10 mm. So let me just measure the dimensions of this. So first of all, what are you thinking about this, right? So do you think that I am going to cut this and make a wing out of it? Right. So instead of that, I would want to fly this entire platform. How many of you can imagine this entire platform as a wing? Which configuration do you prefer, right? Either should I fly something like this? Should I throw it like this, similar to the one that I have demonstrated in the class, where I checked out aerofoil, a wing made out of an aerofoil, but here we have a flat plate, and I think mostly it is a square, right? So let me just measure the dimensions. So I can see it's 0.9 meters cross 0.9 meters. Yeah, I can see this. It's 0.9 cross 0.9. You can have a look at it. So close to 0.9. 0.99, I'm sorry, 0.99 meters, not 0.9. Yeah, it is 0.99 cross 0.99. So this is again 0.99 cross 0.99. Yes, we have a square here. Thank you. So I need your help. Prabhajit, I want you to be here. So today is Sunday, so I don't have much of my research staff available other than Prabhajit. I'll trouble him a bit. So how should I make this fly? As soon as I look at this, I immediately imagine it like a kite, right? A diamond shape, a diamond wing. So can I imagine this as my wing? How many of you thought that I will turn it to this particular orientation? Right? So I consider the diagonal, one of this diagonal as the root chord, right? And I have no tip chord here, right? So it is, the taper ratio is 0. So do you remember we have solved example problem during these lectures? So in that, the root chord is about, if I remember properly, the diagonal is about 0.1 meter, right? But in this case, it will be a bit different because the sides are 0.1 meter, close to 1 meter each side. So, and then the diagonal must be close to root over 2, which is 1.414 meters. So the diagonal or the root chord is 1.414 meters, and I don't have a tip chord here. So the taper ratio is 0, and it is tapered about? Yes, it is tapered about mid chord, isn't it? At each and every location, if you take a section, right, span-wise section, if you measure the chord, then, and if you figure out what is the mid chord of that particular span-wise location, so then you will be, if you draw a locus of it, they all lie on the opposite diagonal here, right? Say this is one diagonal, which is the root chord of our configuration here, and then on the opposite diagonal, you will find all the taper axis. You will find the taper axis of this, which is in fact the midpoint of the midpoint of the chords at each and every span-wise location. Now, how to make this fly? You can see this is very weak. Let me add two structural members to this, so that just like what we used to make, during your childhood. We used to make a kite, right? So I'm just, this is a carbon tube. I'm just trying to strengthen this with this carbon tube, strengthen this platform, and I'm using a masking tape for that. So one carbon tube, I'll use it near the root cord, the other one on the perpendicular diagonal. So I have used one carbon tube along the root cord. Say this is my root cord, right? So I'll try to add the other carbon tube which is here. So I'm trying to add this on the other diagonal, right? So we have one diagonal. I'm sorry. So we have added carbon tube along the root cord which we considered as one diagonal. So on the upper surface perpendicular to it, I'm adding this other carbon tube. Right? So while adding this, Prabhjit, you try to press this surface up, right? Otherwise, because, or you can do this way. Yeah. So first let me complete with this portion and then we can, okay? Yeah, so I think this is good enough. Yes. Or do you want me to add some more here? So let me add a small tube. Yeah, so we just finished adding these two tubes. So one on the bottom side of this platform, the other one on the top side, right, on the top surface. So now, so it's not so weak, compared to what we had earlier. It's not so weak. Yes, right. So assume that this is my root cord. So this is how I want this. If I attach a motor to this, right, one brushless motor along with a battery, I expect this to fly. But in the first place, will it fly? So what is the weight of this particular? Yeah, so let me just figure out what is the weight of this platform along with these tubes, which is about 345 grams, right? This is close to 345 grams. So this one. And now, as you know, so this is almost a constant thickness flat plate, and we have a homogeneous carbon tubes, right? Two carbon tubes added, almost symmetrically distributed about this plane of symmetry, right? Let us assume this tube is my plane of symmetry. So the other tube is also almost symmetrically distributed, right? The mass of the tube as well as the geometry. So I can safely assume that the CG must be acting at the centroid of this. Am I correct or not? Which is, say, 0.7 meters along the diagonal, or say 0.5 comma 0.5 meters, right? If we consider this as the origin of this coordinate frame, so I say 0.5 comma 0.5 will be this particular point, which is the intersection of this point of intersection of diagonals. So the current CG is at this particular location, and we know the mean aerodynamic chord is also, it will be somewhere along the spanwise location, and it is also tapered about its mid chord, isn't it? Mid chord of the mean aerodynamic chord, midpoint of the mid aerodynamic chord. Now when you project that, you will be able to figure out what is the corresponding aerodynamic center. Am I correct or not? So 2/3 of root chord. So 2/3 of root chord is how much? So we have 1 meter side and 1 meter side. This must be 1.4 meters. 2/3 of this 1.4 meters will be approximately 0.9. Yeah, 0.94. Yeah. So this is approximately 0.94. C bar will be 0.94. Am I correct or not? So somewhere here, whose length is 0.94 will be the corresponding C bar. So if I project that, so with respect to root chord, Yeah. So with respect to root chord, I know C by 2, CR by 2 minus C bar by 2, right? That will be the distance between leading edge of the root chord and the leading edge of the mean aerodynamic chord plus C bar by 4, right? So that turns out to be approximately 0.47 meters, right? So which is this particular line. This is my location of aerodynamic center, right? So for a wing alone configuration, if it has to be stable, my CG should be ahead of the aerodynamic center, isn't it? Here, wing aerodynamic center of the wing. I know what is the location of my aerodynamic center, which is about 0.47 meters. Now I have to shift this CG, the current CG, which is at 0.7, to ahead of aerodynamic center, let us say. Now, for that, what should I do? I need to add some weight here, right? So let me just add some weight. Can you help me, Pravijay? So what I did right now, just added a 200 grams weight, right, near to the leading edge of this root chord. So by doing that, what I achieve is shift a new CG location, which is ahead of the aerodynamic center here. So can you notice this? I am able to balance this model about this particular location, right? So I just calculated what should be the weight of the what should be the weight that I need to add so that I can shift the CG location, say 3 centimeters or 4 centimeters ahead of the neutral point. No? And I know I fixed the location of the weight that I want to add, right? So I fixed it. The total weight should be at, or the weight of this object is acting at about 25 mm from the leading edge here, right? So from there I was able to figure out, and now the current CG is at this particular location, and this is my aerodynamic center. Say, if you want, I can locate this. Do you have a marker here? So say this is my aerodynamic center, right? So the current CG is close to this point. Okay, so good enough. This is ahead of the aerodynamic center. We'll talk about this, how much, what should be a typical offset between this aerodynamic center and the center of gravity. That we'll talk in the coming lectures. But for the time being, let us see whatever we have derived, will it work for any configuration or not? Or say, will it work for a flat plate or not? That's what we are going to do right now. So the current CG location is at this particular point. Now let's go out and try to check this out and see whether this will fly or not, right? And then once we have a flight, then we'll also remove the weight and we'll also check this out and we'll see what is its behavior. Okay, so we are on the tarmac and I'm on a chair on the tarmac of flight laboratory. So you can see we have our classroom is located inside the flight laboratory. So it's a hangar of our flight laboratory. We have multiple powered aircraft as well as powered gliders. So yeah, that's where our runway is located, and this is the way for that runway. Right now you may not be able to see. Yeah, so let's go ahead with our demonstration. So this is a flat plate again. So we have our AC somewhere close to this, and we have now shifted the CG location by adding a weight to the desired point, or say ahead of the aerodynamic center here for this wing alone configuration. Now let us see whether it will be able to glide or not, right? So if at all it glides, that means, yeah, so whatever we did is correct, right? So whatever we have derived in our lecture hall is correct. So let me throw it. So Kaji, please try to catch this. Okay, so our second TA, Salahuddin Kaji, so he is here to help us. So I'll try to throw this and see whether it will be able to glide or not. Right? Wow, isn't it good? Yeah. So I'll try to throw it at the minimum possible angle. Wow. Yeah. So let me do it one more time. So Kazi, now don't try to catch this. Let us see how far it can glide, right? Okay. Am I throwing it properly, or you want me to decrease the angle? Wow. Right? So one more time. So do you accept it? It's able to glide because of the CG location. Do you accept it or not? Okay. So let me do it again. Yeah. Okay. Fine. Fine. Now let's see what happens when we remove this weight. Right? So let's see what happens when we remove this weight, additional weight. So right now I have removed that additional. So I'm sure that it's not going to like travel till the grass. I don't want to damage this. So I'll try to stand here. Okay? So Kazi, then you can be, yeah, here itself. Yeah, there. So now the CG again shifted back to the centroid of this, right? Let's see. I haven't done anything, right? So I didn't like try anything new. So see, I'm trying to cautiously throw it with the same angle what I tried earlier with an added weight. So you better move out, right? Okay. So see this. So no, it's not happening. So we have to maintain CG ahead of the aerodynamic center. Okay, so let me do it one more time. You may not believe this. Right, so let me also put the angle a bit more down, right? I am trying to throw it down. See, whatever I do, it is just flipping, right? It is in an unstable mode right now. So since, yeah, now you will be in a better state to appreciate the location of the center of gravity with respect to aerodynamic center for wing alone configuration, right? So let's now, can you see this ATC, air traffic control tower here? Can you see the tower? So I would like to climb it up and then throw it from there. Let's see what happens. So I'm now adding the weight and then bringing again the CG to the same location what we did earlier. Bringing CG ahead of the aerodynamic center. I'm throwing this again. As you know, this is a low aspect ratio wing. B square by S is almost close to 2. So we can't expect much glide ratio with this configuration.